Good evening, everyone. I'm Dr. Sarika Chauhan, Chair of the Program Committee at Ethics Society. It is my pleasure to welcome you all to the Masterclass 26, Designing Extended Reality XR Environments for Education. Before we begin, let me tell you a bit about who we are. So, Ethics Society is a professional association started in India by individuals who are committed to improve instructions and learning through the use of educational technologies. Ethics Society members are researchers, developers, and practitioners in the field of educational technology. Joining Ethics Society offers numerous benefits like networking and collaborations with experts in educational technology, opportunities for professional growth, affiliation with international associations, awards, scholarships, and internship programs, reduced registration fees for annual conferences and faculty development programs, winter and summer schools, access to key resources and best practices in educational technology. We also conduct various events like Masterclass, Industry Talk, In Focus interviews, Perspectives, a panel discussion, and T4A International Conference, and many more. So join us and unlock a world of opportunities in educational technologies. For more details, you can visit our website etsociety.org. Now, let me introduce our esteemed speaker for today's masterclass, Dr. Herold P C, who holds a Ph.D. in educational technology along with an M.Des in interaction design from IIT Bombay and a B.E. in electronics and communication engineering. He has more than 3 years of experience in software industry. His research focuses on extended reality XR design for education, user experience design, and interactive product design. Presently, he is a visiting faculty member at multiple design institutes in India. So, on behalf of EdTech Society, I extend a warm welcome to our esteemed speaker, Dr. Herold. We are delighted to have you here today. And before I hand
Yeah,
over the session to the expert, there is an announcement for the participants. You can post your queries using the comment section, and the answers will be given towards the end of the sessions. So now I request Dr. Herold to begin the session. Thank you.
yeah,
Over to you.
yeah. Thank you, Dr. Sarika, uh, for introducing and for uh, this opportunity. I will start sharing the screen. Uh, I hope the screen is visible.
Yes, your screen is visible. Yes.
Yeah. So today uh, we are going to hi everyone. First of all, thanks for joining the masterclass. So today we will be looking at designing extended reality environments for education. Mainly, it will be focused on people who want to design these kind of environments, helpful for engineers, and pretty much whoever is enthusiastic about these emerging technologies. So my relevant experience regarding this field is my PhD in Center for Educational Technology, where I worked on a VR platform uh, specifically on civics education. My M.Des from IDC, where I worked on augmented reality application for mathematics education. And I have a teaching experience on two courses, which is human computer interaction design for educational technology and a short course on interaction design for immersive systems. So with this, in this talk, I will be looking at three objectives. One, mainly clarify the distinct characteristics and real-world applications of various VR, AR, and MR across the different sectors, including education. Second objective is to discuss key factors such as immersion, presence, interactivity, and agency to determine the most suitable XR experience for a specific topic or a challenge that you are currently working on. And once we kind of decide on which XR environment to go with, we will be looking at the third objective, which is explore essential design frameworks and processes that can guide the design of XR environment. Specifically, we will be looking at an extended Garrett's model to guide the XR design process, and also we'll be looking at camel model for immersive learning. So going ahead, XR is kind of basically an umbrella term for a lot of different technologies which got developed over a period of time, starting with virtual reality applications, where VR is specifically in the left end of spectrum, where you will be completely putting a device, VR device, and you will be shut off from the real world, but you will be engrossed in a virtual created world or a illusionary world. And the opposite end of the spectrum is augmented reality, which is just simple mobile phones like Snapchat, in which you overlay things on it, which doesn't have much of interactions, possibility of interacting with the virtual objects in them, not there in those kind of things. And in between, there is a mix of those interaction possibility available when we move from left to center, and when we move from the left to this side, we will get more and more of interaction capabilities. So mixed reality platforms usually combine the features of both, and there are other experiences also like the cave, the void, and Pokemon Go and AR, other things which kind of fall in between these categories. So usually XR is an umbrella term to define all these kind of emerging techs. We will specifically look at VR, AR, and MR in this thing. So starting with VR, it's kind of a media system capable of simulating and imitating real and imagined worlds through head-mounted displays and sensory control units. So these are the kind of devices that are pretty much available in the market, which has different tracking capabilities and sensing capabilities. But in terms of virtual reality environments, we can pretty much classify the different kinds of experiences into these four. One is cinematic VR, where pretty much there are recorded 360 videos or 3D content, which often has a spatial audio in it, but there is no possibility for interaction with hand and body, apart from the fact that you can move your head around. So that's pretty much the interaction there. I'll just show an example where this was a project that I worked on where we were able to, it was a music video that we made where this could be seen through a VR device where you will be transported. You can explore different, like you move from day to night and things like all these different impossible things through other platforms can be tried out on this. This is one. The next type is interactive VR, where there is a possibility of interacting in these environments using your hand, or even you can move through the environment by walking or running to manipulate or move around the object. Say, for example, this one is a maroon VR application, which usually you will find it in as a virtual lab, where in this, as you see, he's able to move, catch and move the magnet around using his hand. And based on those interactions, he's able to see the feedback on them. He can control the different parameters, see how it's affecting. So this is a physics simulator where a lot of experiments are kept where you can directly control and manipulate them and interact with them. The third kind of experiences involve usually haptics and kinesthetics, where usually tactile feedback is also very much part of the experience. Tactile meaning not just hand, but also there are body suits and things to make you feel immersed into an actual setup, or for you to feel wind is blowing on you, or for you to feel that you are touching a rugged surface or things like that.
Haptic gloves offer the promise of immersive touch in virtual and augmented
So
reality.
something like this.
Unfortunately, current systems are
So how it works out is
the edges of this
there
box.
is
In this demo, a user can feel
you
the
will be able to
individual
see that
violin
in the
strings to
right
help correctly position their hands.
when they press the violin, these
Similarly,
things give
users
you
can
an
feel skin deformation when grasping
force. It's
or
basically
hitting
small
virtual
actuators,
objects. We can also vary
small actuators which kind of give you the feeling of haptic and touch. And this, when integrated with the VR environment, tries to actually immerse you with those interactions. And the fourth kind is social VR, where these kind of experiences enable social interactions, or you'll be able to do virtual meetings and shared room experiences, or be it a virtual classroom in which different people come together to learn certain things. Say, for example, this is one kind of experience where students are sitting inside the classroom and a virtual teacher is trying to explore all these virtual elements when multiple people are wearing a VR headset and trying to explore these experiences. So, since more people are coming together into a common virtual environment, this becomes a social VR aspect. So, these kind of VR environments is available for us to explore. Next,
haptic gloves.
we will go into the AR environments. So the basic difference in between VR and AR is a technology that predominantly focuses on overlaying digital information such as images, sounds, or virtual environments, but onto real-world environments. And always you will be seeing the real-time world within you, onto which augmented objects are there. And even in this, there are two variants in which this AR technology works, which is one is marker based and one is markerless. So usually in marker based AR, you have a physical marker like a QR code which is kept for reference so that the computer knows where to augment the virtual objects on the screen, and so that you can with that reference point do different other operations. So I'll just show an example. This is a project that I worked for my master's, where I was trying to teach the concept of exponents and powers in maths education. um,
We are going to learn the concept of exponents and powers.
so here
Make one more eraser. Same black lines.
normal eraser was made into a marker, and we could detect that as a
As
marker,
per our case, closer.
and
We
we could do several operations on it. Like when I press,
visualize the erasers
we
that
can
we
augment
have been made.
different objects as if
Then try dividing by
multiple erasers come into the room, and show that when we multiply by 3 or 3 power 2, 3 power 3 is actually very um, exponentially increases, in the sense it rapidly increases, and we show it through the rapid way in which it fills the room. The other next type of AR is markerless AR, where we don't need a marker especially to augment objects, but the technology of computer vision and spatial computing basically allows us to scan the room and place the objects wherever we require. So this you might have usually seen in applications of Amazon and purchase kind of things, where you will be trying out different furnitures in your room and things like that, where you kind of scan the room first and place the objects and manipulate them using the screen. So this is with respect to augmented reality. And next, moving to mixed reality environments, it's nothing but a blend of augmented reality and virtual reality, where digital and physical worlds interact in real time. But the major difference here is Apart in augmented reality, the focus is not much on interactions with the directly with the virtual objects. So here, with mixed reality platforms, you will be able to see the real world by wearing these kind of specialized head-mounted displays, but also you will be able to interact with those virtual environment or the virtual objects within those environment using your hand or controllers. So this is one example in terms of um, aircraft training for participants. And if you see something, so here you can see they have worn it, and there are different things that are augmented onto the actual real world setting things. And there are different simulations that can be tried out, and people can directly interact with those elements that get augmented into the real world objects, and helps you in training different things. So both these AR and MR environments heavily use these two technologies, which is computer vision, which drives the object recognition, motion tracking, gesture detection, and environmental understanding that's needed for AR, and also spatial computing, which helps in like object anchoring and ensures that virtual objects are realistically integrated in a user's environment. And nowadays, with this technology rapidly evolving, both of these use the power of artificial intelligence and image processing and machine learning to enhance the quality of immersion and presence. So, with this, we saw a spectrum of AR, VR, and MR. Now, let's just reflect for a few seconds. I'm going to tell you about an XR experience. What you need to think on is what kind of XR environment can make this kind of experience possible? Will it be AR, VR, or MR? So I will read the experience. A student is trying out a new XR environment, and she is able to see a virtual object on her notebook in front of her. And while pressing a button, it showed a simulation of a car engine. Later, she also cranked the wheel on the virtual object using her hands to see the feedback on the engine. So just think for a minute, which kind of XR, whether it's AR, VR, or MR, will make this kind of experience possible? So an important thing to note is here the experience says that the virtual objects on her notebook in front of her. So clearly this experience requires real world environment to be seen. So it's definitely not VR. So while pressing a button, it showed a simulation of car engine. So this can be possible both in AR and MR, where because I can see a simulation in front of a book by pressing a button in the tablet so that I could see the simulation. But later they say that she also cranked the wheel on the virtual object using her hand. So this is not possible through AR because with AR, you won't be able to track the hand and use that as a method to manipulate the objects directly, the virtual objects. So the correct answer will be MR. I hope all got it right. So now let's move ahead to the next part, which is trying to figure out what are the different key factors which will be important for us to look at uh, while working on a specific challenge of your own or a specific topic of your own, and which XR environment will be much more appropriate. You will be able to decide through some of these factors. So before getting to these factors, I'll just talk about a simple cycle which is usually which works out in an AR, in a VR, AR, or MR um, experience. So usually in terms of the human factors and cognition, how this thing works is usually in the left you see a virtual world generator, which is kind of the VR headset or an AR or MR headset, which kind of generates different virtual objects, and these is output through a lens, which or through a speaker, which you through your senses of hearing, vision, and touch kind of perceive them. This after we perceive, the next step that happens is this goes into your brain, and these signals get processed. Say for example, I'm seeing an apple in on a tree in the virtual world generator or VR headset. I will be able to see the apple which is falling down, and I will also be able to hear it falling down. And naturally the brain, looking at these signals, will try to say that there is an apple and it is trying to fall down uh, from the tree. So after this point, what the brain can do is, it brain can again control back your senses, try to
Okay. So I think there is a network issue at the speaker side. By the time, I just request all the participants to please post your questions, if any, in the YouTube comment section. We'll be just back shortly. Okay, so I
so
think there was some network issue. So, Dr. Herold, can you just share your screen? I can see you now. You are live. Yes.
yeah, I will share it again. Where did I lose? uh,
Yeah. So you can just start with
maybe
your. I'll just let you.
this slide 15,
Yes. Yes. Yes.
this slide.
Yes, sir. Yes. You can
Shall I
continue.
start from the
Yes.
beginning in this slide?
Yeah, if you can. Yeah.
Yeah, okay. So basically what I was talking here is how the extended reality platforms make this extension of reality happen. So usually these MR and VR platforms have this cycle happening again and again. So what happens is, um, we have a virtual world generator which can kind of make these virtual worlds or virtual objects, which is given as output through the lens or through a screen, which we can sense or perceive, which is hearing, vision, or using our touch senses. So this is the first part. But after sensing and perceiving things, these neural signals are sent to the brain, and through cognition, we try to process these signals. Say, for example, an apple is hanging in a tree and it is falling down, and you, through your vision and hearing, are able to see and hear that apple is falling, and your brain processes that this action has happened, and the brain then controls your senses again for you to kind of rotate your head down so that you can see the where the apple is falling down. So this action is very important because this action needs to be recorded or tracked in every extended reality environment so that we can regenerate the image that needs to be shown in the virtual world. Say, for example, when I bend down my head, that action needs to be tracked using an accelerometer or different sensing devices, which is embedded in the virtual world generator so that it this can be taken as input, and once again this image will be refreshed such a way that even though your head moved, the tree position gets anchored in the same place, but you will be able to see the position of the apple falling. So this section of trying to put these stimuli till the perception level is usually what determines the immersion of a virtual world generator. So how much ever the degree to which your senses are presented with substitute information will determine the level of immersion. So if you are immersing them only with vision and hearing, probably we are not immersing them fully as if it's a real world. Say, for example, in the apple and tree case, if you are able to feel the wind as well through haptic gloves and other suits, then it will be much more immersive. So even though so this immersion is not a plain dimensional thing. It can have different dimensions to it. So immersion is possible through sensory immersion, where through our senses we are trying to stimulate the user's senses primarily through visual, auditory, and tactile. There is physical immersion where this aspect pertains to users' physical involvement, often with movement, moving up and down, or interactions within virtual space, or focusing on cognitive immersion. That is, this focus on the degree of attention and mental engagement the user has with the virtual environment, or affective immersion, which is the emotional engagement in this one, where users experience emotions as if they are in a virtual environment. So this part is immersion, but immersion need not uh, get actually transferred in the form of actual reality unless you have a greater sense of presence. So that's the next term, which is mainly controlled by the second part of this diagram, which is presence is the degree to which your brain is accepting the sensory information as reality. So whenever we are creating these XR environments, our focus is to improve or bring more and more immersion into the experience. But that how do we measure the immersion has happened or not is through the metric of presence, in the sense how well are we able to perceive or accept that whatever is getting stimulated is real or not needs to be measured. And the uh, one who says that he's having higher presence means that he actually feels that he's in a real world and not a fake one. So these two are very significant terms. And why this is important is this presence is a tricky thing. So just to illustrate that, I would like to show this video. It's called a McGurk effect, and just look at how this guy utters a word or a syllable, and just let me know, or just think on what you are hearing. I'll just play the video.
Have a look at this. What do you hear?
So this is the first video. I guess you might have heard some syllables.
But look what happens when we change the picture.
So this is the second video. Now let's look at this video simultaneously. Once you look at the left video and once you look at the right video, see whether you hear the same syllable or not.
Hearing
In the illusion,
occurs because what you are seeing now to the left of the screen. The illusion occurs because what you are
So pretty much, I guess most of you might have heard pa
seeing clashes with what
when you see the person in the right, but the same person in the left seems to be saying the word va. But actually, in essence, both these videos, the guy is saying the word ba, the second one. So what's actually happening here is the visual senses of our of humans usually overrides or overpowers the auditory senses. So that's why this effect is called McGurk effect, and that's why you usually need to be very careful about human perception on how these senses, even though we perceive it, how they are processed in your brain is very critical for us to look at as well. So the takeaway from this one is that studying human perception reveals how the brain transforms sensory input into the experiences we perceive, and different XR devices engage certain senses while neglecting others. And this can lead to sensory conflict. Say, for example, see, imagine that you are wearing a VR headset and you are just running, not physically, but in virtual world, the screen is moving in a fast way, as if telling your visual senses that you are running. But your auditory senses doesn't respond in the same way, and your vestibular senses doesn't give you signals to your brain saying that you are running. So this causes sensory conflict, and this causes discomfort for many of the users who are using VR MR, and this can heavily make the presence to be lost. So these are critical factors which might be want to be looked at while designing the interactions for these environments, which we will look at in some more time. But this underlines the significance of understanding immersion presence through the lens of human perceptions. So we discussed degree of immersion leads to presence, which is a key factor for differentiating XR environments, because usually VR provides the greatest degree of immersion, and AR kind of provides lesser degrees of immersion in terms of the physical immersion and the dimensions of tactile immersion, not on the cognitive or the affective parts, because definitely AR can give cognitive immersion, but when considering all dimensions of immersion, VR is the one which provides most degree of immersion. And the other important factor is the level of interactivity that is there and the user control that is there in each of these environments. And why this, how this will affect us, this will lead to a sense of agency. And for us, for edtech researchers or learning enthusiasts, why presence and sense of agency matters is because through research by different people from McCransky and others, have found that it influences different cognitive and affective factors that play a role in immersive learning. So considering these factors are going to be critical while trying to figure out which of the environment is much suitable for you, how much degree of immersion you need for the problem that you are considering, and which kind of learning outcomes are your goal. So based on this consolidating, I'll just present a few consolidated things on when to use AR, when to use MR, and when to use VR. So use AR when real world context is crucial, when the low priority for when there is low priority for high interactivity or user control, and when the challenge does not require much of physical and tactile immersion. In those cases, try to start with AR. Use MR when dynamic interaction between physical and digital elements are necessary, where collaborative workspaces are very important, like say architecture or design review, which happens in a team together in the same space, or where there is field work requiring high immersion, say for example in surgeries or complex industrial operations, where uh, user people need to learn manufacturing by overlaying different things on the real world elements. And you try to use MR when full immersion is needed and when complete control over simulation are needed. Like for example, in flight simulations or trainings, you don't want to see the external world at all, and you want to have complete control over what I want to do and how the system to should react on whatever I do. So that may not be possible if I show the real world as well while doing this. And use VR when you want to show remote experiences. So concluding on this, let's reflect on a short reflection activity, which is let's look at two challenges. Try to reflect on for each challenge, which would be the most appropriate XR environment to choose. So I'll look at the first challenge. So a civics education teacher realized the need to help students understand diverse perspectives of fellow individuals in public scenarios, such as navigating city roads while driving and making decisions in various on-road situations. So in this situation, which XR environment do you think could be suitable based on the factors of immersion or based on interactivity and control? Let's just think for a few seconds. So the critical thing to note here is we need to show diverse perspectives, and it is a you have to navigating city roads while driving. So driving is a situation where you may have to, it's almost like the flight simulator situation where you need to have complete control, and you need to have all kinds of interactions possible through brakes, accelerators, steering wheel, and all these, and also have the virtual environment react based on your inputs. So definitely AR is not possible and MR is also not possible. So the correct approach to go for this challenge would be VR environment. Looking at the second challenge, an electronics professor is trying to visualize the flow of electrons between various electronic components in his physical lab and explain how various like varying certain parameters affect the current. So for this challenge, let's just think on what would be the appropriate XR technology to go with. So here, the important thing to note is physical lab, and he wants to overlay or visualize certain flow of electrons with the components. So physical lab, if it needs to be visible, definitely VR is not possible. So it is between AR and MR. So if we look at the next line, that is explain how varying parameters affect current. So varying parameters is if the professor decides that I need to directly physically go and manipulate the physical devices and make the visualizations react accordingly, or directly manipulate the virtual objects that are embedded over it, uh, and directly go towards it with your hand and manipulate, then MR might be required. But otherwise, if you say, I just need to show different possible visualizations through a button press in which I can just show these electron movements for different resistance values, say for example, where I can just select the resistance values in my screen itself. Though if that is the level of interactivity and control that's decided, then probably AR will be sufficient. So now, once we kind of have a rough idea of which kind of XR experience to go with, the next step is to design them actually. So designing is going to be definitely a long process and an iterative process. And what I usually use in my courses is this Garrett's model, which is an established model in UX design field, but I have extended it to designing XR by including different methods which are relevant for each of these layers. So I'll just first brief the layers through which we may have to go through, and then I will go one by one on each layer. So starting with the first layer, which is basically strategy, where that's where you start off by identifying the problem and learners' needs. And usually that's the point of inspiration for us to create something. And for that to happen from ground, from the learners, you may have to use certain methods like contextual inquiry and empathy mapping, where it's essentially you trying to interview people and get their interests and their problems and their needs. And this is the place we will also look at why we need XR to try to solve this problem. We need to reflect, strategize in this layer, starting from below. So this is the most abstract thing that we start off with while designing something. Then we slowly move into the concrete parts. So next is trying to scope down things, which is narrowing down the content requirements and the pedagogical strategies. And for this, we usually use methods like affinity mapping. We do extensive literature review, and where we look at the different pedagogical strategies, learning theories, and tech principles. And we also start the idea brainstorming. Once we have kind of narrowed down on the core requirements or the core idea, how what it should an idea should have, then we go into the next layer of structuring that idea, where we try kind of prioritize the content or the info and model the interactions between those content. So typically, for prioritizing the info, we use information architecture. But for modeling the interactions, we use a technique called body storming. And I will come to that later. And we do a representational technique called, we represent it through Gom's model. And then we storyboard the entire structure. After prioritizing and getting to model the interactions, next step is to lay out the content in the chosen XR platform and design the navigation. So at this point, we will be thinking more towards what are all the UI design heuristics that needs to be considered, what are the multimedia principles that needs to be considered, and we will start building low fidelity prototype and slowly transition to high fidelity prototype in this space. And while we transition to high fidelity prototype, we will move into the surface layer and we will start thinking of the actual design, the visual, auditory, and haptic features that needs to be embedded within these interactions or within these um, uh, in these experiences, and for which we will be using the principles of visual design. We will be using color theory, typography, sound design, and haptic patterns. So this gives you a initial prototype with which you can start working with. And after this, you will be actually iterating again and again um, to rework or revisit any problems that you find in the scoping part or while structuring, because you tend to structure things wrongly. And when you do the high fidelity prototype and actually do the evaluation with usability testing and looking at different presence and body ownership questionnaires and scores, there are different methods. I won't be focusing much on the usability and evaluation part in this talk, but that's very critical for iterating on this model again and again. So I'll just go through each of these layers in a small bit. So it's difficult to entirely explain what contextual inquiry is, what are all the steps, and what empathy mapping is, and all those. So what I have done is these are good video materials which you can scan and watch later to understand the process of contextual inquiry and empathy mapping, which helps us build the strategy for our design. And to guide us to justify why XR part, there is a nice framework given by Jeremy Valenson from Experience on Demand book, where it's called a DICE framework, where you can justify that if your challenge involves a dangerous situation which cannot be replicated, then probably go with VR or XR. If it's like, say, for example, firefighting scenarios, training them is dangerous, go with XR. Impossible scenarios like you becoming an atom inside an molecule, or becoming a blood vessel inside your blood system, that's impossible to actually do. So justify that because it's impossible, go with XR. Or if it's counterproductive, or if it's expensive, like expensive in the sense going as a virtual tour to some other place and doing things like that. So this kind of gets us to a place where we have a problem statement, and we are trying to refine on trying to see how we can solve or ideate or try to scope the problem that we have and build ideas. And this is the place where we try to scope using literature review. So one key literature model I would like to just quickly share with you is Camel model for VRLE, which kind of talks about the things that we already discussed, which is immersion, the control factor, which is interactivity, and representational fidelity, and presence and agency, and the different cognitive and affective factors which affect learning outcomes. So what you see here is a structure equation modeling diagram, where each of these parts that are there kind of has weights which are determined through this statistical method, trying to say how much of an influence is there from immersion to have better presence, and what is the influence of presence on each of these factors, which in turn influences these learning outcomes. So one critical thing to note here is, if you see in this, all these kind of has positive scores, which kind of indicates that when you have presence, when the presence is high, mostly your situational interest will be more, your intrinsic motivation will be more, there will be more embodiment, and there will be high cognitive load as well. But here for self-regulation, they have put it as plus or minus. What it means is, say, presence is not always good, because um, self-regulation requires different metacognitive processes, where you will be having to reflect, plan, and monitor. And sometimes higher immersion and presence can lead to, or lead us to forget these reflective practices, unless if it is part of the instructional strategy. So that's why they have put a plus or minus. That means if your instructional strategy has catered to reflection spots, making them do self-reflection and metacognitive activities, then having high presence will have a positive effect on learning, including others, but not the otherwise. So in this way, it's important to look at these factors while trying to scope which is more important for your own challenge or focus area, and start brainstorming using any of the how might we method or scamper method. Next, we go into the structuring these idea. Once we have a rough idea, we start structuring them using a technique called body storming. So what body storming essentially is very specific to XR environments. Usually you might have heard brainstorming, but body storming is kind of we are using our entire body to further refine our ideas. So what essentially this technique involves is you create dummy objects of the virtual objects that you intend to make in your environment. And in the step two, you basically enact what and all interactions you are going to do. So if you see the picture here, you'll be able to see this guy holding a straw kind of thing, acting as if he's worn a VR device, and he becomes a user, and he tries to do all the things that he has envisioned for that experience. And here in the left, there is an expert who tries to look at these interactions and say, based on the level of immersivity and presence, they tries to give feedback on whether this set of interactions will help you build presence or lose presence. So those kind of discussions happen through this technique between the expert and the designer. And before making any prototype or anything, this will help you structure or build shape to the different kinds of interactions that are possible, because XR and VR environments has a range of new types of interactions that are not available with desktop or keyboard based interaction methods. And from this point we get into representing that. So in my course usually I do represent it using a GOMS model. The references for that is there in the paper. And once this part is structuring of all these interactions are done, next we go to the layouting part or building the skeleton for it. So for low fidelity prototyping, I usually use these two tools, either Bessie.com or a Figma. And for high fidelity prototyping, it's either Unity or Unreal Engine. And in terms of the design heuristics, there are a ton of them, but I have just mentioned a few important ones, which are like optimal positioning of interface elements to minimize vergence accommodation. What it means is, usually when we put objects very close to our eyes has to accommodate by bringing it together like this towards the nose. So that has to be avoided very especially for these head-mounted display kind of experiences. And always you need to render your objects at least 2 meters away from the user's point of view to minimize this vergence accommodation mismatch. Then another thing is center the interface elements requiring frequent actions, because in VR and MR experiences with current technology, we only have a field of view of around 110 degree, and we don't have a peripheral vision. And this becomes a critical factor due to that. Set units of virtual world to match the real world, so that all your interactions feel as if you do in the real world. And prioritize safety, because you can hit different objects and you need to have specific elements and cues for user to communicate that there are other things that are around and you need to do it safely. And there is also Mayer's multimedia principles, which are still relevant and valid for all the XR designing experience, which was explained in this video snippet. And finally, the surface layer, where we look at the visual design principles, and I have put the links for each of these elements of design, color theory and typography, and also sound design, because this MR experience also has the capacity to give spatial audio and also to uh, improve any sensory conflict. We also need to take care of Doppler effect needs to be integrated in audio design, because Usually in real world, we hear things as if when they come close to you, the sound comes down and comes up and things. Those needs to be simulated properly in the virtual world also. So overall, when we reach this, we will have a minimum viable prototype with which we can iterate. And usually in Unity, this is the development pipeline which I usually follow, starting with XR camera, setting up the camera controllers, modeling the objects, defining the material and physics engine, do the animation for objects and keyframing or scripting, UI canvas element integration for building the interactions, scripting the behavior of objects for user interactions, integrate the spatial audio and haptics, and render them for the platform, be it a MetaQuest or Vision Pro or anything, and try to build your experience through this form. So with this, I would like to conclude my talk. And yeah, thank you for joining. This is my profile details, and now I'm open to take questions.
Okay, so we have few questions. So Sandeep, so Nathan Jose has written, what are the softwares used to make these things like VR, AR, and XR?
Animation.
You are not audible. I think there is a network issue. Speaker side. Okay, I think so. We can just convey your questions to. We'll just wait for him to join and then. By the time I request everyone to just post questions if you have any. So let me give you one our upcoming event details. That is our masterclass, which is scheduled on 8th of February at 6 p.m. on empowering cybersecurity education insights for educator, researchers, and students by Dr. Florence Martin, Professor of Learning Design and Technology, North Carolina State University, USA. So I request whoever is interested, we have already posted this on our LinkedIn social media. Please join us for this exciting masterclass. Okay, so we have Dr. Herold back. Yeah. So there is a question from Nidhin Jose. Which softwares used to make, these, like which softwares we can use?
So usually we use for low fidelity prototyping, we go for BESI or Figma. And when we transition to making high fidelity prototypes, we go in with softwares like Unity, Unreal Engine. And usually the coding happens in with C# scripts where all the logic is built. And usually for modeling and things, 3D modeling and things, we can use a range of tools like Blender, 3ds Max, or other freely available online assets in the Unity Asset Store and things like that. And pretty much this can help you build a basic prototype which can be built as an app. And
Okay. So we have one more participant, Sandeep Rebade. He's saying like he's from Kolhapur, Maharashtra, and he's also pursuing his PhD in VR for medical domain.
okay, oh nice to see that. Yeah, lot of domains has XR applications. Yeah, it's great.
Yes.
Lot of opportunities there.
Yes. So one personal question from my side. How can we ensure accessibility and inclusivity when designing the XR environment, especially for the diverse learners?
Hmm. So accessibility is going to be definitely a key factor. Ensuring it needs to be taken special consideration while we are strategizing and scoping our problems in the Garrett's model, as I was saying. So it needs to be taken care right in those points where we have that as a specific requirement while scoping through our design process, so that it gets translated up to the interactions. So it needs to be decided in this place so that it gets reflected in the structural part and the skeleton and the actual thing that we see and interact with. So for different kinds of learners with different, like some might not have the ability to perceive all kinds of senses or input or interact using all kinds of senses. So for them, these kind of considerations needs to be specifically taken right while we scope the problem and then later on move on to make ensure that this happens.
Yes, correct. So we have two more questions here from the participants. Can I convert AC/DC generator simulations for students to VR? Is again the question is from Nitin Josh.
Yeah, yes, definitely. So one thing we need to look at is whether what kind of experience are you trying to look at and what kind of learning outcomes are you trying to focus on. So if it is kind of a space where you are wanting to make this ACDC input given to different components of electronics and trying to see how different parameters when changed changes in a uh, regular VR lab itself, where there is no need for you to collaborate with other participants or like with mentors who are there in the physical world, then probably VR is also fine. But an easier way to do it would be easier or faster way to do it would be try things with AR application where you can use simple markers and make them as virtual objects which can visualize different um, things, as I said in the challenge two, in the one of these slides. So it's definitely possible. Uh, it's just
Okay.
that we need to start working on these layers.
Yes. So we'll take this last question, like which HMD you prefer at the beginning for development?
So HMD wise, right now Oculus Quest 2 um, offers all advantage of doing things for VR, but Oculus Quest 2 doesn't have the support for doing mixed reality things like MR. So Oculus Quest 3 has all these capabilities of doing MR and VR. So if you have a bit of more money, then I would prefer uh, MR, where you can explore both VR interactions and MR interactions. But if it's too much, then it's better to start with a smaller device. Oculus Quest 2 is its prices have come down substantially, and it can provide all kinds of startup kits. Like there are toolkits available within the Unity platform for Oculus Quest 2, which you can ready-made directly integrate or import in your setup and start experiencing and tweaking small things using the toolkit, and from there learn on the process. So in terms of VR, that's the starting point. In terms of AR, you can directly start doing things using your mobile or tablet.
Okay. Thank you. There is one more, like he has written, Nitin Josh, I have made it using Godot. Is it possible convert to VR?
I may have to check what are the porting facilities given by Godot.
Okay.
Maybe might be possible. We have to check.
Okay. So now I think there are no more questions. So as we come to the end of this insightful masterclass, I wanted to express my heartfelt thanks to everyone for their participation and engagement. My sincere gratitude to Dr. Herold for accepting our invitation and sharing his valuable insights and expertise on designing XR environment for education. Your session truly inspired us to think differently about learning and leaving us with much to reflect on and apply in our work. So we deeply appreciate the time and knowledge you have shared with us today. Thank you once again. Thank you,
Yeah,
sir.
thank you. Thank
Yeah.
you so much for the opportunity.
Yes. Successful conduct of this event wouldn't have been possible without the strong support and guidance of our mentors, Dr. Sridhar Iyer sir, Briju sir, and Dr. Lakshmi Ganesh. Special mention to our technical team members, Dr. Yogendra Pal, Vivek Sabanwar, Nagesh Bokle, and Sandeep Yadav, and for their invaluable efforts. Thank you, everyone. So to our participants, thank you for your active engagement and thoughtful questions. Thank you once again for being part of this masterclass, and we look forward to your participations in our future events too. So I wanted to make few announcements for the participants. You need to attempt the quiz and fill the feedback form, which will be available in your EdTech Society dashboard after you log into your account to get the certificate for this masterclass. So thank you once again for being part of this enriching experience. Thank you, everyone.
Yeah, thank you.
Thank you.